we're about to start a mini unit that is ostensibly about basic image processing and image processing algorithms. But truly, the purpose of this little mini unit is to think more deeply about how to use objects in our programming, or in other words, how to do object-oriented programming. And we'll do that from the perspective of somebody using objects defined by another person, using classes written by another person. So far, we've used a bunch of different kinds of objects. We've used system.out, which has methods print and println or printline. We've used scanner objects, which have methods like nextDouble, like nextInt, like nextLine. And we've used string objects which have methods like length and char@. Okay, and the purpose here is that objects let us do really complicated things in simple ways without getting bogged down in details. We call that abstraction. Objects allow us to abstract fairly complex operations into pretty simple actions that we can take, methods. Now we'll take that same idea and we'll represent images as objects so that we can do fairly complicated things with those that if we didn't have object-oriented programming would actually be much more complex to do. So when you're looking at an image, essentially you're looking at a grid of colored dots, okay? And we call those colored dots pixels. Each pixel contains a little bit of information about the color for one tiny little piece of the image, and whatever software you're using maps the bits, the zeros and ones from a particular image into a rectangular area to display. It displays those pixels in a rectangular grid. Now, the way we do coordinates with a screen or with an image is actually a little bit different from the Cartesian coordinates that maybe you're used to from math class. And essentially, it's not too complicated, but we use 0, 0 in the upper left corner of the screen. Okay, and then we head to the left and down to width -1, height -1, where width and height are dimensions counted in the number of pixels. Okay, we call this the screen coordinate system. So that means that the x-coordinate increases positively toward the right of the grid, and the y-coordinates increase positively toward the bottom. Now, to illustrate this, I've taken the most beautiful photograph I could find, and I zoom in 3 times until we can see just a single pixel. That's what this little tiny yellow dot in the image all the way to the right is. And a pixel is made up of 3 individual values that are all combined together. So those 3 values are a red value, a blue value, and a green value. And essentially, it's like we're mixing these 3 colors as if they were paints. We're saying how much red is there, how much blue is there, how much green is there. And when we combine those images, we get a different final color. So in this case, this little pixel from my beard has a red value of 92, a blue value of 40, and a green value of 52. We call this the RGB space for red, green, blue. That's how we encode them in that order, red, then green, then blue. You can see a bunch of different colors. So black is 0, 0, 0. White is 255, 255, 255. That represents the span of each element, red, green, and blue. Each one is mapped from 0 to 255. Now you might remember from a problem we did before that in hex, that goes from 0 to FF. But in decimal, 0 to 255. And that leads to about 16, 17 million possible colors. So here's an example of a digital image. This is a .png file. It's 636 pixels across by 423 pixels tall. And the way you should think about that is the number of columns and the number of rows of pixels. Columns first, rows second. So if we're writing a package of classes or using a package of classes that can help us manipulate images, there are really 4 basic things we want to be able to do. Okay, the most basic 2 of them are get an image from a file, store it in the working memory of the computer so that we can do stuff. That's one thing. And then at the end, we're probably going to want to take that image after we've modified it or used it or done something to it and save it back to the file. So, sending an image to or from working memory where we actually use it. Those are 2 important things. The other 2 things are we want to be able to get information about any particular pixel, for instance, what's its position, what's its color, and we want to be able to modify information about any particular pixel. The net result is we can combine these 4 basic operations into some really complicated things, right? If you think about the entire suite of Photoshop and all the things Photoshop can do, you can ultimately boil it down into those 4 operations. Now, not all of the algorithms are that complicated. Some of them are actually surprisingly simple. So, for example, let's think about converting a color image to grayscale. Well, it'll be helpful for us to understand exactly what grayscale means. And for us, that really means that we're going to represent a grayscale color as the set of all possible colors where the three values, red, green, and blue, where all three RGB values are the same. So 0, 0, 0 is a grayscale color. 1, 1, 1 is a grayscale color, and so on, all the way up to 255, 255, 255. So in other words, we have to take a full set of RGB colors where the red, green, and blue values could be anything from 0 to 255, and we need to map them onto this one particular set where all three are the same. Okay, so essentially, the gist of how we would convert an image to grayscale, or at least one way we could convert an image to grayscale, is we could go through and convert every pixel and compute a new RGB value that sort of represents a grayscale value that makes sense for that pixel. So we're mapping a full color pixel onto this grayscale space. And the way we do that is we're just going to average the three values, the red, green, and blue color values for that pixel. So here's some pseudocode for an algorithm that does that. For each pixel P, okay, P is what we're calling the pixel. For each pixel P in the image, we're going to set red to P's red values. Okay, so we're taking that pixel's R value, that pixel's red value, and we're setting it to some variable called red. Okay, then we're going to set green to whatever the pixel's green value is, and we're going to set blue to whatever the pixel's blue value is. Great. So we have red, green, and blue stored, whatever the original red, green, and blue. Then we calculate an average, and we just set it to a variable called average. So red plus green plus blue divided by 3, we store that in average. Okay, and then finally we go back and we set the pixel's red value from whatever it was to the average. We do the same for the green value of the pixel, and we do the same for the blue value of the pixel. So you see, at first, we're getting information about the pixel, then we're deciding what we're going to do with the pixel, and then we're setting information about the pixel. That's what this looks like. And don't get bogged down in integer division or any syntax. This is pseudocode. This is really just meant for us to think through the problem first. Okay, so we're going to see in a little bit how we actually implement this algorithm, and we'll use a particular package of classes that make image processing pretty straightforward for us. In the meantime, before you close up shop, make sure you can do these three things. You want to be able to tell me, what is a pixel, just in English. How's the screen coordinate system work, and describe for me an algorithm I could use to convert an image to grayscale.